Overview. Learning the basics of Java.
Are you ready to discover one of the world's most popular programming languages? Java is celebrated for its versatility, high performance, and the vast support of a global developer community. Originally launched by Sun Microsystems, now Oracle, in 1995, Java powers everything from web platforms and mobile apps to large-scale enterprise systems.
A key reason for Java's widespread success is the write once, run anywhere principle. This means you can write your code once, then deploy it effortlessly across various devices and operating systems, thanks to the Java Virtual Machine, JVM. Add to that a rich collection of libraries and frameworks, plus an object-oriented design that's beginner-friendly yet robust enough for complex projects.
Whether you're stepping into programming for the first time or looking to build massive, mission-critical solutions, Java offers a solid foundation that continues to shape the modern software landscape.
Object-oriented and platform-independent.
Java follows an object-oriented programming (OOP) paradigm, making code reusable and easier to manage. Its write once, run anywhere (WARA) capability allows Java programs to run on any system with a Java Virtual Machine, JVM.
Known for robustness, security, and wide community support.
Robustness. Java has strong memory management and exception handling.
Security. Features like bytecode verification and built-in security mechanisms help prevent vulnerabilities.
Wide community support. With millions of developers worldwide, Java has extensive documentation, frameworks, and tools.
Java is one of the most widely used programming languages due to its powerful features. Let us break down the key aspects that make Java stand out.
1. Simple and easy to learn. Java is designed to be beginner-friendly, with a clear and readable syntax similar to C and C++. Unlike low-level languages, Java handles many complex processes automatically, such as memory management and garbage collection. This makes it easier for developers to focus on logic rather than system-level details.
2. Object-oriented programming, OOP. Java follows the OOP paradigm, which means it is based on objects and classes. This approach provides several advantages: code reusability using inheritance, data security using encapsulation, better modularity by breaking programs into objects.
This makes Java ideal for building scalable and maintainable applications.
3. Platform independence, JVM. Java follows the write once, run anywhere principle. When Java code is compiled, it is converted into bytecode, which runs on the Java Virtual Machine, JVM. Since JVMs exist for almost every operating system, including Windows, macOS, and Linux, Java applications can run anywhere without modification.
4. Automatic memory management. Java features garbage collection, GC, which automatically removes unused objects from memory. This helps prevent memory leaks and improves application performance. Developers do not need to manually allocate and deallocate memory, making Java more efficient and reducing errors.
5. Rich API and libraries. Java comes with an extensive application programming interface, API, that includes pre-built classes and methods for networking, HTTP, FTP, TCP, IP, data handling, I/O operations, file management, security, encryption, authentication, graphical interfaces, Swing, JavaFX.
This makes Java versatile for building web apps, mobile apps, and enterprise-level systems.
6. Multi-threading support. Java allows multiple tasks to run concurrently using multi-threading. This improves performance in applications that need to handle multiple requests at the same time, such as web servers and real-time applications. Java's built-in thread class and runnable interface make it easy to implement multi-threading.
Why do these features matter? Java's simplicity, security, and cross-platform nature make it ideal for AOA, enterprise applications, banks, healthcare, e-commerce. AOA, mobile development, Android apps use Java. AOA, big data and AI applications, used in Apache Hadoop and machine learning frameworks. AOA, cloud computing and microservices, Spring Boot, Kubernetes.
Java development environment. To start coding in Java, you need the right tools. This includes installing the Java Development Kit, or JDK, and choosing an integrated development environment, also known as an IDE.
1. Java Development Kit, or JDK. The JDK is required to write, compile, and run Java programs. It includes
the Java compiler, which translates Java code into a format the computer can understand. The Java Runtime Environment, or JRE, which allows Java programs to run. The Java Virtual Machine, or JVM, which makes Java platform independent, meaning it can run on different operating systems.
To install the JDK,
go to the official Oracle JDK or OpenJDK website. Download the version that matches your operating system. Follow the installation instructions. To verify the installation, open a command prompt or terminal and type
Java version.
If Java is installed correctly, it will display the version number.
2. Integrated Development Environment, or IDE. An IDE makes writing Java programs easier by providing tools like a text editor, debugger, and compiler in one place.
Some popular IDEs for Java include AOA, Eclipse, which is free and widely used, AOA, IntelliJ IDEA, which offers smart coding suggestions, AOA, NetBeans, which is simple and beginner-friendly.
Using an IDE helps with
auto-completion, which suggests code while you type, syntax highlighting, making the code easier to read, debugging tools, which help find and fix errors faster.
To set up an IDE,
download and install your preferred IDE. Open the IDE and create a new Java project. Configure the JDK path in the settings. Write a simple Java program, run it, and verify that you get the expected result. Some sample programs are available on GitHub. The link is provided in the description. Java Fundamentals. Java fundamentals include essential concepts that form the foundation of Java programming.
Variables and data types define how data is stored and managed in a program, including numbers, text, and Boolean values.
Operators perform operations on variables and values, including arithmetic calculations, logical comparisons, and decision-making.
Control statements allow programs to make decisions and execute tasks repeatedly using conditions and loops.
Methods and functions help organize code by defining reusable blocks that perform specific tasks.
Classes and objects are the core of object-oriented programming in Java, where classes define the structure and objects represent real-world entities.
1. Variables and data types. In Java, variables are used to store data, and each variable has a data type that determines what kind of value it can hold.
Here are some common data types in Java and what they are used for.
Int stores whole numbers, such as 10, 50, or -5. Float stores decimal numbers, such as 3.14 or 2.5. Double is similar to float but holds higher precision, for example, 3.141592. Char stores a single character, like the letter A or B. String stores a sequence of characters, such as hello, Java. Boolean stores true or false, often used in decision-making. 2. Operators. Operators perform operations on variables and values in Java. Java supports different types of operators.
Arithmetic operators are used for mathematical calculations, including addition, subtraction, multiplication, division, and finding the remainder.
Comparison operators are used to compare values, determining if one is greater, less than, or equal to another.
Logical operators are used for combining multiple conditions, helping in decision-making by checking multiple expressions together.
3. Control statements. Control statements allow programs to make decisions and repeat tasks based on conditions.
If-else statement is used for decision-making, where a specific block of code executes if a condition is met, otherwise, an alternate block runs.
Loops are used to execute a block of code multiple times, helping automate repetitive tasks.
For loop repeats a task a fixed number of times.
While loop continues execution as long as a specified condition remains true. 4. Methods and functions. Methods allow code to be reused and help keep programs organized by breaking them into smaller, manageable parts.
Defining a method involves creating a reusable block of code that performs a specific task.
Calling a method executes the predefined instructions within that method.
Methods with parameters allow passing values to a method, making it more flexible and dynamic.
5. Classes and objects. Java is an object-oriented programming language, meaning everything revolves around classes and objects.
A class is a blueprint that defines attributes and behaviors.
An object is an instance of a class, representing real-world entities with specific properties and actions.